In the last video I had a 1-axis CNC machine, if that's such a thing, and in this video I've got a 2-axis CNC machine. So the last one I was talking about programming and all the elements of the program and how it all runs, and in this one I'm putting the x-axis together and setting up the backlash, connecting it all up and giving it a test. So now I'll be able to machine out things a lot quicker, and it will help with the MGF project that I'm working on as well. Also, while I'm machining out some of the components for the x-axis, I'll put the tools down here so you can see what I'm using. And I put in one of the top corners the CAD element so you know what part I'm actually machining out. If you want to jump to a specific point in the video, just have a look at the description box and I put in a timestamp so you can just click on that and it will take you straight to it. I hope you like this video. Please feel free to put the comments below and give it a thumbs up. And also hit the subscribe button if you want to be notified of new content on my channel. Thank you. So the y-axis being CNC has already sped up the milling process, where all I have to do is drop the z-axis, press the button and it runs to its soft end stops. So this part is the main x-axis block that actually bolts to the end of the table and also supports the lead screw. I decided to stick with the lead screw as a ball screw at this point would just be extra cost. And also I can take the backlash out quite successfully in the software. But as you can see, there's a lot to do when manual milling, where you've got to think about all the features and hold down the part so nothing comes in contact with the cutting bit, then run it through a rough cut, measure the tolerance and then run a finishing cut. Whereas if the X and Y were both CNC, I could just set it to a 0 point at the corner, run the program and it will cut virtually all the features and I'll have a finished part at the end of it. So all I do is set up some soft end stops, tell it where to start and where to finish, and then I control the Z-axis and just hit the button to move it forward or backwards. As you can see, I'm using the joypad control to move the y-axis backwards and forwards. Hopefully setting up the rotary table is going to be a thing of the past, because not only does it take up a lot of space in the z-axis, but it also takes quite some time to set up, as you can see. Now I'm getting faster at setting up this rotary table, although it would be far better for the x and y axis to draw a circle at whatever size I wanted it at a given location. And that's exactly what the CNC side of it does. The milling machine's still on its wobbly table, so apologies for the shaky video. So this is my prototype board with everything thrown on the top and then underneath the milling machine. It's handy for where the milling machine is, but it's annoying if I knock it and I could damage some wires. So I just made this quick box, painted it with chalk paint, added another display, and now I've got a better CNC controller. Also I've added an emergency stop button, but at the moment the emergency stop is actually external. So I'll just let that calibrate. It has to do a calibration at the start unless I use different encoders, but I don't mind because it only moves by 0.5 millimeter. And then I can jog the machine to the exact point I want it using the joypad. Enter soft stop mode and then select the two extremities on the y-axis. Select the speed for the y plus and the y minus. Run the y-axis and then I can just let the code worry about where to stop the machine. I've only had one error so far and you'll see that a little bit later. So this feature is where the motor is going to be mounted. And with the CNC it looks quite neat. So it needs this little slot so I can get to the Grub-Screw for the motor pulley. Otherwise I won't be able to put it on and off, as I found with the Y-axis. As you can see, the machine keeps moving location, and this is because I don't like it sitting in the lounge all the time. Although when I'm doing programming on the Arduino, the microprocessor, it's handy to have it sitting next to the desk. So this part is one of the end plates, and it doesn't take too long to cut out. I could do it on the miter saw, although it's late at night, so I decided to do it on the milling machine. So this part's got 4 holes in it that is counterbored to let the heads of the hex bolts sit flush with the surface. So for each one of these holes I need to do 4 processes, and that is find the centre, spot drill it so the drill bit runs true, drill it with a 4mm bit, then counterbore it with a 7mm end mill, where when it's a CNC it will spot drill all 4 holes, then drill all 4 holes, and then counterbore all them holes. So 3 steps instead of 16, which will save even more time. With the rotary encoder mount, there wasn't enough room to put the rotary encoder and the clamps that are required on the back of the motor, so I had to mill out this pocket so it would sit a little bit deeper. Bit of an afterthought. Oh, and make sure you know which way the table is going to move before you press the buttons, otherwise you could end up pushing the clamp off the part with a milling bit. Luckily there was no damage and I carried on using that milling bit.
Jesus, got some power.
So here I'm using both Y-axis CNC and Z-axis manual just to cut out the profile. Then you use the joypad to cut out the excess. So with the lead screw, I needed a keyway in a different place, so I needed to machine this out. Set it up on the Y-axis CNC and then just run the end stops again. Sorry about the blurry video, it looked good on the camera screen. So the pulley fits nicely, it just needs a little bit taken off of the key, just so it doesn't protrude and rub against the bearing. Now again, I could have just used the chop saw, but being late at night it's a little bit loud, so I decided to chop this off with a 3mm end mill. And why not while you've got a CNC Y-axis? Need a couple of keyways here, so I'll just mark it with a blue pen. Doesn't have to be blue, you can choose any colour you like. So I haven't got a handle at the moment to move the X-axis backwards and forwards, so I'm just using 2 bars and an 8mm bit just to find the centre of the bar, and that actually works quite well. Again, use the CNC side of it, makes life a lot easier. Just machine out the keyway. These are steel shafts, they're not aluminium shafts, although they do look like aluminium in some shots. So setting up the motor, make sure it's nice and square with the table, just using a level. Marking out where the hole's going to go. Putting the pulley on and then drilling a hole through. Now this hole is going to go all the way through to the other side of the pulley, and this is so I can tap all the way through the shaft and push against the other side of the pulley. I feel that although the shaft is slightly weaker, there's 2 points on the pulley that are preventing it rotating, and I find it holds a lot better. So mounting the rotary encoder, I've allowed a little room so it can be moved around, because it needs to be dead centre of the motor's rear shaft. So there's 2 elements to this to lock it into the shaft, and because it's an 8mm shaft I need the blue insert and that goes on first, and then the cap that rotates the rotary encoder. So you push that on with a little tool, so that's nice and secure. And as you can see, it rotates with the brushless motor, and this has 8,192 pulses per revolution, and there's 2 revolutions to the motor to 1mm, so I've got 16,384 pulses per millimeter, and I can run that at the moment with 12 volts up to 300,000 counts per second, so that's quite rapid. Make sure the rotary encoder's in the centre, and then just give it a few turns with your hand just to make sure that there's no rubbing or grinding on there. So I decided to test it out first with the y-axis output, just to make sure everything's working and the table's going backwards and forwards and there's no grinding. Although you can hear the keys hitting the keyways as it's rotating, but I've sorted that out now. So all that it needs now is an ODrive sticker and have its own wires connected to the ODrive. This box is temporary and only made out of MDF. When the milling machine is fully working and when the MGF project is fully underway, I'll make a new box for this. But at the moment it doesn't look too bad with its chalk paint. So the ODrive has 2 3-phase motor outputs where I like to solder the cables on just to make sure that I've got a good electrical connection, because the last thing I want is these falling off while I'm milling something. So back inside next to the desk to test it all out. So I've got my dial caliper set up with a couple of springs and touching the back of the riser. This so I can measure the backlash. So I'll just move it in both directions just to check that it hits 0 as it runs through, and I run it at different speeds as well because I want it to hit 0 at a slow speed and hit 0 at a fast speed as well. And as you can see, the backlash has been taken out, where the x-axis has around 0.25 of a mil backlash, and the y-axis has about 0.12 of a mil. So now that's all set up, I just need to run a couple of test programs, just to make sure everything's running properly and it's not going to fail at any point. So the first test pattern is just a bunch of circles, and it will start at a slow speed and speed up, but I'll speed up the video so you won't get too bored. So the second pattern is testing lines at different angles, and then it will draw some circles at different arc lengths, and then lines again, just to make sure everything's running smoothly. Oh, and I knocked the camera as well, but the video will be back in a second. Also, the circles are a lot smoother when run at a slower speed, and this is what will happen when I'm machining that sort of feature. So you won't get the jagged edges as you can see on these circles. Well, I hope you've enjoyed this video, and I hope to see you in the next one. As I say, if you've got any thoughts or comments, please put them in the comment section below, and I'll try my best to get back to you.